This is section 13.8, the double angle and half angle formulas for sine and cosine. Today we're going to learn how to use the double angle and half angle formulas using sine and cosine. Now, I know this chapter, especially all these formulas, are coming in very, very quickly. So do your best to memorize them, to process them, and again, I would encourage you to use flashcards. And frankly, memorizing the equations is only half the problem. The other half is actually applying them correctly. So this is your first exposure to these things probably, and it's not easy. So do your best, and I know some of you have many other things going on in the classes. So the double angle formulas are for sine of 2 alpha and the cosine of 2 alpha. How do we figure out what those are equal to? You can use addition formulas that we learned yesterday. So let's start with sine of 2 alpha. The sine of 2 alpha equals the sine of alpha plus alpha. Now, if we use the addition formula we used yesterday, we get sine alpha cosine alpha plus cosine alpha sine alpha. We can combine those and conclude that sine of 2 alpha equals 2 sine alpha cosine alpha. So this represents the double angle formula for sine. Sine of 2 alpha equals 2 sine alpha cosine alpha. For cosine, we can do the same thing. So cosine of 2 alpha equals cosine of alpha plus alpha. Using our addition formula, this means cosine alpha minus sine alpha, which we can reduce to cosine squared alpha minus sine squared alpha. So that is the formula for the cosine of 2 alpha, the double angle formula for cosine. Now, you will also see it expressed in two other ways, and they are derived from using the identity sine squared alpha plus cosine squared alpha equals 1. First, if you take away the cosine squared and substitute 1 minus sine squared, you get that the cosine of 2 alpha also equals 1 minus 2 sine squared alpha. If you substitute for sine squared by putting in cosine squared minus 1, you will get that the cosine of 2 alpha equals 2 cosine squared alpha minus 1. So, if you substitute for negative sine squared, you will get cosine squared minus 1. You move the 1 over here, you move the sine squared over there. So, you'll see it expressed all three ways, and you might use any of those three depending on what angles they give you. Take a look at example 1. If sine of alpha is 4/5 and alpha is in the second quadrant, find the sine of 2 alpha and cosine of 2 alpha. Alright, the second quadrant part is kind of important because that will tell you whether the answer is going to be negative or positive, and that's something you're going to have to decide. So first we need to figure out what cosine of alpha is. If alpha is in the second quadrant, is the cosine of alpha negative or positive? Well, if you remember, the second quadrant is over in the top left. The top left, we know sine is positive and cosine is negative. So, since it's negative, the cosine of alpha equals negative the square root of 1 minus sine squared alpha. This comes from a rearrangement of the sine squared alpha plus cosine squared alpha equals 1 formula. So since it's negative, we stick a negative sign in front of the square root. Now we just plug in sine squared. So cosine equals negative 1 minus the square root of 4/5 squared, or negative the square root of 9/25. So cosine of alpha equals negative 3/5. So again, conclude whether cosine is negative based on which quadrant you're in. Then plug it into the formula for cosine alpha using the Pythagorean identity. Put the negative sign in front because you're in the second quadrant, and then simplify. Now that we know the sine is 4/5 and cosine is negative 3/5, we can use those to figure out what sine of 2 alpha and cosine of 2 alpha are. So the sine of 2 alpha is 2 sine alpha cosine alpha. So now it's just a matter of plugging things in. So plug in 2 times 4/5 for sine alpha and negative 3/5 for cosine alpha, and the sine of 2 alpha is negative 24/25. For the cosine of alpha, 2 alpha, here's your formula, cosine squared alpha minus sine squared alpha. You could use one of the other formulas too, actually. And so you get negative 3/5 squared minus 4/5 squared, which comes out to negative 7/25. Now, you're right. If you just used 1 minus 2 sine squared alpha, you would have gotten the same thing. You would have gotten 1 minus 32/25, which is negative 7/25. So for the cosine of 2 alpha, you actually did not need to figure out what the cosine of alpha was. And that's the freedom of using the cosine of 2 alpha formula, is that you really only need either sine or cosine to get the answer. But here I use both, and the answer is the same no matter which way you do it. Example 2a. Simplify 2 sine 17 cosine 17 to a single angle without evaluating, which means don't calculate it. So, what you need to do here is identify the pattern in the question. Does this look like the sine of 2 alpha or the cosine of 2 alpha? Well, it's this sine double angle formula. So, that means that sine of 2 times 17 degrees equals 2 sine 17 cosine 17, where 17 degrees serves as the alpha. So sine of 2 alpha equals 2 sine alpha cosine alpha. That means to simplify it to a single angle, we're going to take a look at this side. So we're looking at the sine of 34 degrees. So basically we're going backwards. If you see 2 sine alpha cosine alpha, remember that means the sine of 2 alpha. The half-angle formulas. The half-angle formulas can be derived by replacing alpha with theta over 2 in the formulas for the cosine of 2 alpha. Now, I'm not going to prove these or derive these. You can look at the book to see how it's done. I'm just going to show you the formulas. First, the sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. The cosine of theta over 2 equals plus or minus the square root of 1 plus cosine of theta over 2. Notice that these two formulas are almost exactly the same. The only difference is the plus or minus sign in the numerator separating the 1 and the cosine of theta. For cosine of theta over 2, this is a positive sign. For the sine of theta over 2, it's a negative sign. So keep those straight. Cosine positive, sine negative. Remember, cosine goes with cosine there. Now, we have this one little pesky thing with this plus or minus sign. How do we decide which one to use? That's going to depend on what quadrant theta over 2 is in. So you'll know what theta over 2 is, and based on what its value is, you can tell, well, which quadrant am I in? And that will tell you whether to use the plus or minus sign, depending on whether sine or cosine is positive or negative in that quadrant. Example 2b. Simplify to a single angle without evaluating. So, again, you are going to see which formula does this look like. And if you can tell, it looks like 1 plus cosine theta over 2. The value under the radical is 1 plus cosine of 100. So you're going to be using the cosine half angle formula. Here, theta is 100. So that means theta over 2 is going to be 50 degrees. So we are looking to solve cosine of 50 degrees. Again, look at the format. Notice that there's a 1 plus cosine of theta in there. Since it's 1 plus cosine, you're looking at the cosine of theta over 2, where theta is 100. If theta is 100, theta over 2 has to be 50. Let's go to example 3a. Find the exact value of the sine of 5 pi over 8. So, what you're going to have to do is use either a half angle or double angle formula and figure out what theta or alpha is that you can solve it from using the exact values of what you know. So, which formula do we use, and for what value do we use for alpha or theta? Well, we're going to use the half angle formula, and we're going to use theta as 5 pi over 4, because any multiple of pi over 4 we know the exact sine or cosine of, because they're the equivalent of some multiple of 45 degrees. So, let's continue. Now we have to figure out which quadrant is 5 pi over 8 in. And based on which quadrant is the sine of that quadrant going to be positive or negative? Well, 5 pi over 8 is a little more than pi over 2, but it's less than pi. 5 pi over 8, if you convert it, is, I'm not sure how many degrees it is, but you can figure it out. It's in the second quadrant, and therefore, the sine of an angle in the second quadrant is going to be positive. And that will tell you which sign to use when you actually execute the formula. So, the sine of 5 pi over 8 is equal to the square root of 1 minus cosine 5 pi over 4 over 2. So this is the sine half angle formula. Sine of theta over 2, which we're calling 5 pi over 8, is equal to 1 minus cosine of theta, which we're calling 5 pi over 4, all over 2. So, if theta is 5 pi over 4, then theta over 2 is 5 pi over 8. Now it's just a matter of plugging in the value and simplifying. So the cosine of 5 pi over 4 is 1 minus the negative square root 2 over 2. Notice that, by the way, that it's a positive thing here because the sign in the second quadrant is positive. So now you just have to do some algebra. So 1 plus root 2 over 2 over 2. Put the fractions all under one denominator on the top, 2 plus root 2 over 2, which is the same as 2 plus root 2 over 4, square root at the bottom, and you get answer is square root of 2 plus square root of 2 over 2. And that's the answer to 3a. So you're going to use the half angle formula, figure out what theta is by multiplying this thing by 2, and then be careful when you solve for the exact value. Example 3b, find the exact value of cosine of 5 pi over 8. Well, again, let's check. Is the answer going to be positive or negative? We are still in the second quadrant. So is cosine positive or negative in the second quadrant? Blue's Clues moment for pause. Yes, it is negative. So we are going to use the negative half angle formula for cosine. So cosine of 5 pi over 8 equals the negative of the square root of 1 plus cosine of 5 pi over 4 over 2. Remember, if 5 pi over 8 is equal to theta over 2, then theta is 5 pi over 4. And we know the cosine of 5 pi over 4 because 5 pi over 4 is equal to 225 degrees. So, negative the square root of 1 minus root 2 over 2 all over 2. And again, be careful with the algebra and simplifying the fraction. And your answer is negative the square root of 2 minus the square root of 2 all over 2. Lots of 2's. Alright? Now, this is why you don't have to memorize these eighths of pi, but you can calculate the exact value of all those angles if you know the half angle formula. Example 3c, find the exact value of cosine squared 15 degrees minus sine squared 15 degrees. So, see if you can figure out which formula this is, and then find out what the exact value of the resulting angle is. Alright, which formula do you use and value do you use as alpha or theta? Well, this is the double angle of cosine. Remember, double angle cosine is cosine squared alpha minus sine squared alpha equals cosine of 2 alpha. Here, alpha is 15 degrees. So, the cosine of 2 times 15 is equal to cosine squared 15 minus sine squared 15. So, we don't need this side anymore. Well, let's focus on this side. Cosine of 2 times 15 degrees is equal to the cosine of 30, which is equal to radical 3 over 2. And that's how you do example 3c. So you can use the half and double angle formulas as a way to derive the exact values of angles using the exact values of angles of multiples of 30 or 45 degrees. Example 4, we have a proof. Sine of 2 alpha over 1 minus cosine of 2 alpha equals the cotangent of alpha. Alright, so what you're going to do is use the double angle formulas for sine and cosine and try to get what's on the left equal to what's on the right. See if you can give that a try. Remember, you cannot work across the equal sign. You can only work on this side of the equation. Alright, so let's plug in the double angle formulas. I'm going to use 2 sine alpha cosine alpha as a substitute for sine of 2 alpha. And let's use cosine squared alpha minus sine squared alpha for the substitute of cosine of 2 alpha. Alright, now let's plug all those in. And you get 2 sine alpha cosine alpha over 1 minus cosine squared alpha plus sine squared alpha. Notice that all I did was use the associative property of addition. I moved the parentheses. So this is actually 1 minus cosine squared plus sine squared. I basically just put a parentheses around the 1 minus cosine squared. Why? Because then you can see that this is equal to sine squared plus sine squared, since 1 minus cosine squared is sine squared. Now let's keep going. 2 sine squared alpha cosine alpha over 2 sine squared alpha, that takes care of the 2's. That also takes care of one of the signs in the numerator. So you are left with cosine alpha over sine alpha, which, remarkably enough, is the cotangent of alpha. Alright, so you can use the double angle formulas to solve proofs as well. Sometimes they take a little bit of observation and puzzle solving. If you're like me and like to do puzzles, you like this section. If you don't like puzzles, well, sometimes you just got to look hard to see what the answers are. Finally, example 5a. We have alpha between 180 and 360 degrees, and we're told that the cosine of alpha is negative 12 over 13. find the sine of alpha over 2. Alright, so the first thing you want to do is figure out what the range of alpha over 2 is. Since alpha is between 180 and 360, how do you figure out the range of alpha over 2? Well, you just take this inequality and you divide everything by 2. So, alpha over 2 has to be between 180 over 2, which is 90, and 360 over 2, which is 180. Alright, so which quadrant is alpha over 2 in? And based on that quadrant, is the answer to sine of alpha 2 going to be positive or negative? Well, between alpha over 2, between 90 and 180, we are in quadrant 2. And in quadrant 2, the sine of an angle is positive. So when we use the half angle formula, we're going to use a plus sign in front of the square root. So, as I wait for the slide to load, sine of alpha over 2 equals the square root of 1 minus cosine alpha all over 2. Well, we know the cosine alpha here, we just have to plug it in, and because sine is positive in quadrant 2, we leave the positive sign in front of the square root. So let's plug in some numbers. That is equal to 1 plus 12 over 13 over 2, which is 25 over 13 over 2, which is 25 over 26, which is equal to 5 over the square root of 26. Now what you have to do is get the radical out of the denominator because radicals don't like to live in the basement. So do that by multiplying the top and bottom by radical 26. Your final answer for the sine of alpha over 2 is 5 root 26 over 26. So again, you'll have to be careful when you do the simplification here. I'm moving through this pretty fast because you guys should be able to do it by now. So figure out which quadrant alpha over 2 is in, and you can do that by using the range of the original alpha. That'll determine whether sine is positive or negative. In this case, it's positive. They tell you the cosine of alpha, you just plug it in and simplify. 5b. Now we're going to find cosine of alpha over 2. Now, we know alpha over 2 is in quadrant 2 because we did that in 5a. So is cosine of alpha over 2 positive or negative? Well, in the second quadrant, cosine is negative. So you're going to put a negative sign in front of the square root. So we have the cosine of alpha over 2 equals negative the square root of 1 plus cosine alpha over 2. That's the half angle formula for cosine. We know cosine alpha, you just plug that in. So we get 1 plus a negative 12 over 13 all over 2. And if you simplify that, you get negative 1 over the square root of 26. This becomes 126. Square root of 1 is 1. Again, get the radical out of the bottom. I was going to say the bottominator. That doesn't make any sense. And your answer is negative root 26 over 26. So, again, when you work with the half angle formulas and you're confronted with a problem like this, figure out what quadrant alpha over 2 is in. That will tell you whether sine or cosine of that angle is positive or negative, depending on which quadrant. So, a bunch of more formulas to memorize, 4 more. I know it's a lot of material. Do your best. If you have any questions in the meantime, you may ask me questions on email or in class.